Hey everyone, it's been a kind of busy week with work, so I've managed to do a lot on Elite this week. I've been doing some work on tweaking the roll counters so that the bar on the console on the right will move with the roll, same with the pitch, and add some dampening logic in it. Did some work on the stars tweaking there. So that's all looks like it's behaving with the Starfield map, but obviously the problem I was getting was that the ship was looking like a bag of nails. So what I've done this week is looked at the line drawing algorithms. I went through first into the basics of the 3D maths and thought, you know what, I'm going to put it in Excel. It seems to have worked before working out things. So I've taken some sample data from memory where it was generating really, really bad clipping. Taken the values out for the rotational maths, and then I did the algorithms as Excel formula. I thought, you know what, I'm going to go through and validate the Excel with Excel formulas. I've done it independent of the code, using the basic logical formulas there. And what I found was that the numbers within one are accurate. So that's good enough for me. Then I did the same with the vertices calculations. The vertices within one are accurate as well. So that basically means, in theory, my problem is my line clipping. So I started looking at my line clipping. It was dreadful. It was really bad. So I looked at Agra and I thought, I just looks like I did a stream of typing diarrhea rather than actually quality of code. So I decided to rework the algorithm. I've been processing through, and I've got myself a set of data which I think it should generate where it does the clipping. So I've started working on that today. It's been odd going, and I'm feeling pretty zonked out after it. But what I'll do is I'll do a little bit of a show of what the algorithm does. So what I've taken is line clipping algorithm and tried to do a bit of optimization on it. So, for instance, if they're both off the left, then you can discard it. If they're both off the top, you can discard. If they're both off the right, you can discard the points. If both points are off the bottom, you can discard. If they're the same, then you just do a horizontal clip. So you don't have to do any calculation of gradients. It's really fast, efficient logic. If x2 is the same, it's a vertical one, so you can do clipping there. And then finally, if x1 is greater than x2 for the x coordinates, and swap them around, so you can simplify some of the logic that you always know that you're moving across the screen from right to left. Um, then you've got the calculations, a couple of little calculation logic here, which are used through the algorithm. So rather than calculate them repeatedly, calculate them up front. And then I'm going to say if x0 is less than naught, set it to naught, and then adjust the y position accordingly. If y1 is less than naught, you set that to naught, then you adjust x1 position accordingly. If y1 is off the bottom of the screen, now because I've got a console, I've only got 128 pixels to play with, then I set it to 128 there, and then clip x1. Then I can go on to deal with the second point, which I now know can't be negative because the logic has dealt with all that. So I set to 255 and then deal with the Y2 adjustment. And then they're saying do the same thing with the Y coordinates of saying it's 1 to 8. Because in theory, you could clamp this at 255 and send it with a Y2 that's off screen. So it goes through and handles that. Now, I did some optimization on that because the first thing is this calculation of 0 minus x1 is pointless. That just becomes x1. So you just take an ABS of the value, and that's it. You've got the value there, and the calculation flows through. This can be further simplified, getting a bit more towards the style of Z80. If x is match, if y is match, if x is greater than there, you swap the points. If x1 is negative at this point, then you go to the outer bounds clip. The first thing the outer bounds clip does is see if they're both negative and throw it away. Else, if x1 is negative, obviously it must have, so there's another optimization there. it adjusts the X and Y positions and falls into out of bounds clip. Now, I don't need to do a negative test on this bit because it can't be greater than x1, and x1 here is a test for negative, and that does that. Are they both negative check? So in there, I can do a y1 negative check, see if x2's off the screen, y2 negative check to adjust y2, because even if x2's been clipped, it may still fall out, and that's my clipping done. And for the y coordinate, I can then say, well, actually, I don't need to do repeated loops of both coordinates. I can do the y coordinate high byte set here, because when I jumped into x2, I would have dealt with the y here. So by virtue of going in here, I know that the x coordinates don't need touching. So I go into the y outbounds clip. If y is negative, then adjust. If y is too large, then adjust d1. But I also know that because the x1 coordinate was on screen, even the adjustments mean that it should still fit. I'll prove that hopefully when I run the code. Same thing with the y2 high, that we know that the x coordinates are, in theory, should be on screen, so we can do the calculations for those. And then I've got simple vertical and horizontal that just basically see if it's on the screen, and then set it to the maximum, set it to its limits. I haven't put any logic in here for saying if the X position is off the screen, but that's a trivial matter. And I thought, let's go for a bit more optimization now with a bit of a Z80 focused and a bit of a clean up. So chop off go to simple vertical horizontal lines. If x2 and x1 are on the screen, then go to test the y positions, else do the logic for testing the x points. For the y positions as before, I can just go and check to see the bounds clipping on there. I don't need to test y2 because if y1 and y2 are both on screen, then it's fine. If y1 high byte is set, then go to the y bounds clip, which means that the y2 must have a high byte, either it's positive or negative. Now, the important thing is here I've swapped the x1, x2, but you can't obviously swap the y1 and y2, or else you end up flipping the line position. So the next thing on the logic here is I don't bother doing a test to see if x1 and x2, if x2 is negative or not, because I wouldn't hit this routine else. So therefore I can just do a simple calculation there and fall out into the x2 test. Now go through the logic here, go to clipping, same thing happens to the Y, and then simple vertical clip. So I've started writing this code. At that point then, after a few hours of staring at it, I decided to go out with my son and play some crazy golf. I've come back, done a little bit of cleanup, and primarily been working on testing the simple logic. The one bit I've now got to, which is the bit that drives me to despair, is maths in Z80, particularly floating point maths and multiply and divide. You can use the mul DE within ZX Spectrum next to speed multiply, but there isn't the equivalent divide function. And trying to get my head around the calculation of divide needs a bit of a break and a clear head, so I'm actually going to stop at that point because it's driving me round the nut today. So I think I'll stop there, and I'll try and see if we can get some time in the week and tell you how it's going so far in the divide calcs. Bye for now.